Hello everyone, welcome to this next video on field theory. In the last video we saw what is the characteristic of a field. Let me remind you what is it. It is the smallest positive number of ones whose sum is 0. That is called the characteristic of the field. That number, the smallest number, when you add ones that time you'll get 0. That is called the characteristic of the field. If there is no such number such that the sum of all the ones is 0, we say that the characteristic of that field is 0, right? And in the last video, we saw that the characteristic is, we saw an example where the characteristic is 0. What was that? The set of rational numbers. In fact, the set of real numbers and the set of complex numbers, they all have characteristic as 0, right? Moreover, we saw another example that was a binary field Z2, whose characteristic was 2, right? So this we saw in the last video. Now there's a result which says that the characteristic is either 0 or a prime number. That means these are the only possibilities of the characteristic of some field. That means it is either 0 or it is a prime number. That means if you have some number of this form, n is equal to a into b, where what is this? This is a composite number, right? So we are saying that this cannot be the characteristic of any field. Let us see how. Why is this so? Let us suppose that the characteristic is n, where n is equal to some multiplication of two numbers a and b, where so that we can call this as a composite number, right? This both a is less than n and this b is less than n. Then we are saying n is the characteristic of the field f. That means when you add 1, the multiplicative identity, n times, you'll get 0 by the definition of characteristic. That means you can write this thing as this, that if you n into 1, that is equal to 0. That simply means that you just have to add these ones n times, right? So this is obvious. So now what is our n? Our n is equal to ab. So we can replace n with ab. ab into 1 is equal to 0, and we can write this as this. Why? Because you can say that the first ones are a times and the last ones are added b times, right? So that means you can write this as a into 1 and b into 1, that is equal to 0. Now these two, the multiplication of these two is equal to 0. What does that mean? That means that either the first one is 0 or the second one is 0. If the first one is 0 or the second one is 0, this possibility cannot be there. Why? Because in the very starting we have said that the field f has characteristic n. And what do you mean by characteristic? Characteristic means that n is that smallest number such that n into 1 is equal to 0, right? And in this case we have a into 1 is equal to 0 and a is less than n. Similarly, in this case we have b into 1 is equal to 0 and we have b less than n. So that is not possible because n was the smallest number satisfying this thing. Therefore this cannot be true. Therefore we have assumed that n, being a composite number, is the characteristic of any field. That is not possible. So we say that the composite number cannot be characteristic of any number. So the characteristic is either 0 or it is a prime number, right? So this is one important result one should remember. Moreover, if the characteristic is p, then what is the nature of your field? We have said that it represents a feature of the field. So in this case, if the characteristic of a field is p, in that case the sum of elements can the elements of this field could be written as sum of ones replicating zp. So if the characteristic is p, the field is eventually a copy of this field zp. And if the characteristic is 0, the elements form a copy of rational numbers with the usual operations of addition and multiplication. Why is this so? Because the fields having characteristic 0, what are these? They are the field of rational numbers, real numbers and complex numbers, and among these what is the smallest field? It is the field of rational numbers, right? Therefore, we say that if characteristic of the field is equal to 0, then the field is a copy of the field of rational numbers, right? And let us look at the next result. One should also keep this result in mind, that whenever K is a subfield of F, we are given a field F, then K is the subfield, a smaller field, right? Then whatever is the characteristic of this field, the same is the characteristic of this field. Then K and F both have the same characteristic. This is the result, right? You should keep this in mind. Yeah, that's it for this video. Thank you for watching.